Okay, and then welcome everybody on board again. Thank you very much for taking your time to come and join us to learn this beautiful thing. Okay, before we get started, I would like to wish everybody a good time in this tutoring program, and I'll go ahead and ask Esther, as always, to lead us in the word of prayer. Like I said, we will always be putting God first to get started, so that we get good guidance. Okay. Esther, please go ahead and get started with the word of prayer. Thank you.
Yeah, let's pray. Dear Heavenly Father, we thank you for today. Thank you that we have been able to gather here. Thank you that you've given us the gift of having this lesson. We do not take it for granted. Even as we learn, dear God, we ask that you help us understand. You help us capture everything that we are going to learn. And as we continue, we just ask that even as we go on with our projects and do everything, that you may be with us. Thank you for our families. Thank you that they've given us an opportunity to learn as well. In Jesus' name, I pray, believing and trusting.
Amen. Thank you, Esther. All right, again, thank you and welcome everybody. We are going to go ahead and get started, and feel free, please, to raise your hand, okay, in case there's something you did not understand. But we are going to go ahead and get started with a summary of what we learned yesterday. And then after that, then we'll go ahead and proceed to what we are going to be doing today. So yesterday we learned about computer hardware, and we said computer hardware refers to the physical components of a computer system. The physical components are those pieces and bits of the computer you can see and actually touch, like the keyboard, the mouse, the screen, the laptop itself, okay, and even the processor, the desktop. Those are the physical components of a computer system. So today we are going to be able to summarize what we did yesterday, and then we are going to go slowly into what we are going to learn today, which is going to be the software. Software will be the programming or the instruction code which we give the computer to help us understand and be able to process data. When I say data, I mean the facts and figures. It could be the math, it could be the typing you put in there, it could be the speech or the singing you put in the computer, and then the computer process it and then give it back to you in the form of what we call information. Okay, so I'm going to go ahead and let Esther take over. Okay, Esther, go ahead, please.
Okay. So we'll just do a recap of what we covered yesterday. I hope you can all see my screen.
Yes.
So I would like us to participate so that I know whether we are understanding kindly. So you can just either raise your hand or unmute yourself if you have a question. If you're here, if you were there yesterday. So we did introduction to computing, and the first thing is we defined a computer. So I would like to ask, can anyone remind me what a computer is? Anyone? If you don't answer me, I'll pick someone. So it doesn't have to be the exact thing I said. What did you understand? What is a computer?
Okay, two people raising their hands.
Mm-hmm.
Okay, we have Liches and we have Adiola. Okay, we have also have Nicole. It's a lot of people raising their hands, Esther.
Yeah, so you can just pick one. All of them can just tell me
Okay,
what they.
go ahead and just answer. It's okay. You unmute and then you answer.
A machine that processes information, and it processes it. It gets the input, it processes it, and it stores. And then it stores it, and then it outputs the information back to you.
Oh wow, nice.
That's good, son. Very good, godson. All right. Anybody else?
That was, and then before you answer, you tell me your name.
Yes, please. That would be nice. I see Raphael. I see Destiny. I see the chess. They are and also, yeah, they are raising their hands. So anybody can go.
Good morning. I wasn't here yesterday, but what I think a computer is basically like technology that helps store data and create.
Very good, very good. That's the chess. Very good, the chess.
Oh, it's Duchess.
Duchess, all right. I knew I had to get that correction, so thank you. I'm gonna call you Duchess. Okay, thank you. Okay. Anybody else? Raphael, Destiny?
So Raphael can go first.
Raphael, you can go.
I feel like a computer is a device that translates binary, like 1 and 0s, into words for it to understand, and then gives you the, like, if you're searching something on the web and then you ask a simple question like, what is code? There's Python, and I only know Python and binary. There might be other ones, but sometimes Python, since my mom has these classes that she does sometimes, Python is kind of like binary, but it's more complicated.
Yep, okay. We'll learn about that today. Cool, that's nice. Destiny?
Yes, that's Destiny, and then Raphael, and then Chess. Okay.
Did Destiny answer?
Destiny did not. Destiny, do you want to answer? You can go ahead. Go ahead and answer, Destiny.
I'm still thinking.
You still thinking? Okay.
Okay, cool. So all of you have got it correct. So we actually say that a computer is just an electronic device that takes a set of instructions and it executes it. So all your explanations are right. And then we went in and looked how we have different types of computers, how we, interact with computers every time. So I hope now, every time you see a computer around you, you'll be conscious. You'll be like, oh, okay, this is a computer. Like, try and be keen to see all the situations you use the computers. Your TV now you should look at it more like a computer than entertainment. From now on, try and figure out, okay, how does this thing work? Okay, even your other electronics that you have in the house, try and figure out other, and in the you can tell me, like, I found out, you can just text me and tell me, oh, I realized this is a computer. So be keen and look at them. So we looked at the parts of a computer. Here they are, the external parts. You said the external parts are what we can see, and the internal parts are the parts that we can see them, yes, but they're not open. So these are parts inside the computer. So the external parts are labeled, the monitor, keyboard, and speakers. Then the internal parts are the storage, the RAM, the processor, which is the CPU, the power supply, and the motherboard, and other driver unit. So as someone has mentioned, how a computer works is that it gets input, processes it, can either store it or produce output. We said input is the analog form of
Okay. Okay, Miss Godson has his hands up. You have a question, Godson?
Okay.
I just
know why I'm not seeing
I just
them.
wanted to make sure. So I think I didn't hear you guys well, but is internal the part that we can touch and see, and then internal is the part that we can't see?
Okay, so the external, we can actually see both external and internal parts, we can see them. But you see, when you have your computer, there are parts that are actually, we always see them every day. But when you open up a computer, you'll be able to see the internal parts. So
Okay.
both of them, you can see them.
Okay, thank you.
Yeah.
Thank you for the question, Godson.
Yeah. So feel free to ask questions. I think, Judge, please help me because I am not actually seeing the guys who have their hands up.
Okay.
So, yeah.
Okay.
So, yeah.
Go ahead.
So we looked at the input devices. We said these are the parts, these are the devices that enter input. So input can be audio form, where you use your microphone. It can be a physical microphone like this or an inbuilt microphone. So your computer, almost all, I think when you have a good computer, a basic computer has an inbuilt microphone. So as I speak, or as you speak, you're speaking into the microphone built into the computer. When you go to a recording studio, you can speak into the microphone. I think you know those big microphones that guys use to record. And then have others, keyboard, the touch screen on your phone, the keyboard on your phone, a mouse and a stylus, and the joystick that you use to play games with, like the ones to move, turn this. So that is input. Processing, we mentioned processing quite a bit, where we said that what basically does the processing is the CPU. And inside the CPU, we have the arithmetic and logic unit. This
Okay. I'm sorry. Go ahead. Go ahead. Sorry.
You're muted. She's muted. Miss Esther?
Esther.
Is muted.
Oh, sorry. I don't know why I was on mute.
Yeah.
So where did I lose you guys?
I think after you read the stuff in bold.
After?
After you talked about the style, the input devices.
Okay. Oh, sorry. So after the stylus, I went through the processing, where now I said the processing has the main component of the computer that does the processing is the CPU, which has the arithmetic and logic unit, which basically does calculations, which you remember we said is in binary, so it has zeros and ones. So there's zeros and ones, there's always some addition done, there's logic inside that, so you can do the addition, you can choose whether 1 or 0, 0, 1, all that happens in the arithmetic and logic unit. So as we continue, we'll understand what logic is, but I think we know our arithmetic is like basically math, so addition, subtraction. Then we have a control unit. This is what controls what happens, like if this input comes from the keyboard and we want the output to go to the monitor, the control unit kind of controls all that. Whoa, no, what happened? Okay, so we said storage, we had primary and secondary storage. We said primary is the main storage, which now are all storage units found inside the computer. Secondary is any other form of storage outside the computer. So in the primary storage, you can basically say they're also the internal storage of the computer. So we had a hard disk drive, the solid state drive. These are what like contains the static information, like they have big storage space, so they can store a lot of information. The hard drive uses magnetic technology, solid state uses electronic technology. Then I basically gave an example of a library, if you can remember. So the library, like the hard disk and the solid state, are like the bookshelves. See, bookshelves hold a lot of books. But say when you have RAM,
Destiny has her hands up.
mhm.
You have a question, Destiny?
Well, I was wondering if I can say what I know about computer, or
Say again, please.
I was wondering if I can say what I know about computer. Okay.
If you can save.
What I know about computer, like
Oh, okay. Oh, okay.
Oh, okay. Yeah.
Go ahead. Go ahead, Destiny.
a computer is like a electronical technology used like maybe for school, and it's always used in your everyday life. And maybe some people like they use it for meetings, for like maybe their jobs or something like that.
Okay.
Reading what?
What did you say?
What did I didn't get the last part.
Oh, I said that it can be used in your everyday life, and maybe some people can use it for their jobs, like if they can't do it in person. So
Okay.
yeah.
For work, right? Very
Yeah.
good.
Yeah.
Very good, Destiny. That's really good.
Yeah.
Thank you. Thank you.
Yeah, that's true.
Okay.
Yeah. So as I continue, we said like the bookshelf, like in a library, the bookshelves store a lot of books, but when you have a table, you can choose the books you want and you can have as many books as fit on the table. If you have a small table, you have less books. If you have a big table, have more books. So that's how the RAM helps in the multitasking. You know, like how on your computer or on your phone, you can open, like on the phone, you can open several apps, run them at the same time. Or on a computer, you can be like working on a Word document, the same time, you can listen to music at the same time. That's what RAM helps with. Then mention the bias. The bias is sometimes when you're writing, like say your assignment on Word. So you type, you can see whatever you're typing, right? So that means it's being stored somewhere, right? It's being stored somewhere. But in case you forget to save it, your work disappears. Or you get a prompt like this. When you open it back again, you're like, you have to save it or something. So the BIOS is what helps it. Anytime you shut down your computer, whatever was stored in the BIOS, it disappears. So we always have to make sure we save our work so that it is stored in either the hard drive or the solid state. So external storage devices are like a flash drive, external hard drive, memory, I don't know how we call them memory cards, then CD, DVD drives, Blu-ray. So those are external. Then lastly, we mentioned the devices, which are like the screen, your speakers, printers, headphones, and so on and so on. So basically that was it for the computers. Anyone lost so far, or are we cool? If anyone is lost,
are we all together? I think we are all together. So that was a summary of what we did on the hardware parts. So remember, we talked about the input devices, and that takes care of the input as the keyboard, the mouse, the joystick, the stylus, which you normally use. You can do that on your touch screen or on your tablet. And we also talked about the output, that's the printer. Okay, we also talked about the speakers, the plotters, the screen. Okay, and then we also talked about the processor, the arithmetic and the logic unit, where we do the math. That's where the computer does its math and then process the logic. The logic will be like, is it Is it low, greater or less than? That's the logic. If it's less than or greater than, then the computer will be able to decide on that. And then it stores it in the memory. And then in the memory, we have two types. We have the RAM, which is the random access memory. And we call that memory volatile memory. That means when the power goes off before you save your work, you lose it. And then we have the non-volatile, which is the ROM. And that's the one which actually you cannot read, you can read it, but you cannot modify or write onto it. And that's normally the BIOS, okay? And thank you again, Esther, continue the software.
Okay, so now we talked about the hardware and we said hardware is what we can see or feel. Another word is tangible. What you can see, feel, smell, all those are tangible. So now you remember when I talked about me talking to you guys and you being able to see me. So it's not only the hardware. With the hardware by itself, a computer cannot work. So it needs something else that's extra that will assist it in functioning. So that's where we have our software, okay? Software is now all the instructions. Remember we said a computer accepts the instructions. So this can be applications or they are computer programs. They provide now the instructions, software, okay? And software is like what is like between the hardware of the computer. You see, when you have a computer without the software, it's basically like a piece of metal, metal and glass, the screen. You can't do anything with it if it doesn't have software. So software is what comes between you as the user, as the human being who wants to use the computer. So we have two types of software. We have system software and application software. So software is broadly categorized into these two. Okay. And if I lose you somewhere, just raise your hand, please. Don't want to move on if you're lost. So system software is basically what is now software that is in the hardware as I've described, as I've written here. So it enables now the user and the hardware to interact. So it enables the hardware to function properly. So basically, the system software, it manages computer hardware. So this software is like what directs how the hardware will work. So most of the system software work hand in hand with the hardware. Application software are now what, for example, the user wants to do something. So you want to type a Word document, have application software for that. You want to play a game, that's application software. So these are basically designed to fit the user's needs. So system software are software that like direct how the hardware is going to function, like they facilitate proper functioning of the hardware. And then application software is what now enables the user to do what they want. You want to draw on your computer, so there's software that enables you to do that. So, and we always realize that as I continue, application software is built on top of system software. So we have the hardware, then we go to system software, then we go to application software. So someone builds a hardware like an engineer, then there's someone else who comes and creates system software on top of the hardware. Then someone else comes and creates application software. So most of the time, us at home, from home, you can create application software. And if you're nerdy enough, you can do system software. So we'll see. As you continue, you can even build your own computer. So take this seriously and we'll go far with this. So let me continue now from system software, because now you're from hardware. Now go to system software. So when you first turn on the computer, it will be the system software that will run. So the first, it will be like what will be activated. And one of the first is the operating system. An example of operating system will be like Windows, iOS, Android. Those are, and there's another one known as Linux, and many others, I guess. So operating software is now what enables the functioning of the the functioning of the proper functioning of the computer, so that you can be able to run the computer. Because you remember when you open a computer, the first thing that comes up is normally the operating system you have. If you have Windows, it would be Windows. If you have Mac, a Mac computer would be the operating system for the computer itself. So most of the time they provide a graphical user interface. So what does graphical user interface mean? Graphical is like the icons you see, you know, those are like graphics. User is you. An interface is something that is between. So when you click something, say you click an icon for opening a game, say. So that icon, you click it, but there's a message sent to the computer to tell it that this person wants to open this, or this person wants to save this in the documents folder. So the operating system enables that. Okay. So after that, we have the firmware. So firmware, most of the time, say, you remember we talked about the hardware components of a computer, like the hard drive, the RAM, all these, they have the metal part of it, like the construction that we can touch. But when they're being built in the company, there's a certain software that is put inside them to enable the RAM to know that, okay, I am RAM, I am supposed to be storing some input given. I am a CPU, I am supposed to be processing. So that kind of software is built inside these devices and is known as the firmware. Then again, similar to firmware are device drivers. So these device drivers are like when you have other devices, say a printer, say a mouse, say all these other devices that connect to a computer or the storage devices, these are known as, you remember when you say hard disk drive, so these drivers are kinds of software that enable the computer to sense, oh, okay, there's this component that has been connected to me like a printer. And that driver facilitates you to be able to work with the other device. You, like, for example, you want to print a document. That document, you just click print, right? But how will the computer know that I'm supposed to send this to a printer? They are drivers. So that is the software that is inbuilt into, you can download the drivers to the computer, which now that software enables it to communicate, the computer to communicate with the printer. As well, some drivers, you don't have to download them. They come, they are pre-installed. Some you do have to keep updating. So these drivers, so when you see a computer that, oh, okay, the computer senses that I have a mouse. When you connect your computer to a Bluetooth device, those are drivers that are facilitating that connection. It's not magic, it's just the software, the driver software. The other software are like utility softwares. An example of a utility software is antivirus software, or compression software, or defragmentation. Defragmentation is a big word, but it basically means like subdividing into fragments, to small pieces. So sometimes you might want to subdivide your hard drive into parts, or you're always told, keep your computer safe by having an antivirus. That is an example of a utility software. So basically these kinds of softwares ensure, like, the way maintenance, they enable you to maintain your computer in tip-top shape. Like, they maintain the safety of the computer, they maintain the proper functioning of other devices. So that is what utility software is all about. Then we have programming language translators. Programming language translators are basically some types of softwares, which can be, some are known as compilers, interpreters. So when you write a programming language, like someone mentioned Python, that language needs something to translate that language that you've written, because Python, remember we said that computer only understands zeros and ones, and we will look at other forms of programming languages, and most of the time we write programming languages in English. So that we need a kind of software to translate what we have written in English into zeros and ones, so that the computer can understand what we want, the instructions that we are giving to the computer. So that is an example of program translation software. So basically, that's an overview of system software. I hope you kind of have an understanding. You can go back and read, because I just did an overview. You can go and read the notes and see if you can understand. And have I lost anyone so far?
Looks like we're
Okay.
still good, right?
Okay.
All right.
So we continue to the other type of software, which is the application software. So application software most of the time is what we interact with most of the time. And there are different types of, broadly, this, as I mentioned, these are what now are tailor made to suit the user's needs. And they can be categorized according to the needs that the user wants, the budget, or the expectations the user has. So if you expect this software to play a game, let's say I want to play NBA. So I look for a software that does that. I want to draw. So I'd look for a sketching software. I want to edit my videos before I post them on Instagram as Reels. I'll look for that. I want to edit my photos before I post them. I'll look for that. So and in that category, that means some people create softwares to sell. Some people just make them free. So for those that are free, they're known as freeware software. So they are always available for free, but you can't change them. You just download them for free. Like say Facebook, no, you don't pay for Facebook, you don't pay for Instagram, you don't pay for TikTok. Just get them free, but we cannot change anything about Facebook. We cannot change anything about Instagram. Then we have shareware. Shareware, what happens is that, yes, they give us free, but they tell us use this software, a free trial for say 30 days or 14-day trial, and then start paying for it. So some of them are like, most of the software that we download on our computer, you can have like free trial, then you use it, then you start paying for it. That is what is known as shareware. Then open source software are software that is given for free, and a nice thing is that they can allow you to change it. So there are some softwares, and you can look around the internet, you will find some softwares that they tell you can actually change the software to be like, for example, you have I know like there's some editing software that are open source. So you can have a software like it does this. Maybe for example, it saves a file in this format, but me, I want it to save it differently, or I want it to work differently. So I can write my own code and change it, or I can contribute to change it, to making that software better. So that is what they call open source software. And we have this other form of software that from the word go, they tell you you have to buy this software. We're not giving you it for free at all. You have to pay for it. That is what is known as closed source software. So I just gave some examples of softwares. I hope you have seen either one of these. So all these are application softwares. So that is it for application software. Any question, any comments so far? Is it too fast? Am I too slow? How is it so far?
You're doing good.
Oh, wow, thank you.
Sometimes it's a little fast, but I can keep
So
going.
where was I first? What didn't you get?
Oh, I was fine. It was just certain.
So I should go a bit slower.
Okay, if for some reason you think she's fast and you did not get a certain portion, it's okay. Just raise your hand and then we can always go back to that part.
Yeah, I can always repeat.
And then we repeat it for you so you understand.
All right.
All right.
Okay. Anyone else?
I think we're good. Let's proceed.
Okay. So now, do you remember I talked about programming language translators? So we have something known as programming languages. Wow, we have languages for programming. The same way we have English, we have, I don't know if some of you know Swahili. We speak Swahili here in Nairobi in Kenya. Have French. So we have languages, and all these are types of languages. We have C, we have PHP, we have Python, we have Java. All these are forms of languages. So what is a programming language? So it's a language that is used to write this set of instructions. Remember we said we are tying it up to what we did from the beginning. A computer is a device that accepts a set of instructions. So this set of instructions are written in a particular language. So, and people write using different forms of languages. So people just choose, oh, I love this language, so I want to write it. So some people love writing Python, so they write, they use Python to give their computer instructions. Some would use PHP, some would use C. So there are different types of languages. So we have now the types of programming languages. Basically, in a broad perspective, we have two types. And these two types are either low-level languages or high-level languages. So remember when I was telling you how a computer has hardware and system software and application software? So when it comes to the languages, we have languages that are very close to the hardware of the computer. You remember we said a computer understands zeros and ones. So one of the low-level languages is those zeros and ones. People just write 0, 1, 0, 0, 0, 1, 0, 0, until once they're complete with a project. So like someone actually learned how a computer understands and writes that exact code in zeros and ones. So that is known as machine code. But then again, there's also another type of low-level languages known as assembly code. It contains the zeros and ones, but has a bit of English. So in this case, this English needs to be translated into zeros and ones as well. So there's something that comes between the assembly language and the machine to translate it into zeros and ones. But these two languages, machine language and assembly language, are very close to zeros and ones. When you look at it for the first time, be like, what is this? It's like code, like real code. You're looking at it, be like, I really don't get what this is. But the computer loves it so much because it really understands. It's like when you speak to a French person in French, maybe you learn French in school. So for you, French is kind of hard, right? Like the first time you learn it. But when you speak to a French person, they'd be like, wow, this is so simple, because that's what they understand. But for you, you don't understand. So that's the difference between machine language and assembly language. So the advantage is that it will be very fast because the computer will be getting it so fast and working so fast, and it will be very efficient. But a disadvantage is that you as the person who is writing the code, you don't understand it. So even when there's a mistake, you won't even, it will take you so long to find where the mistake was, you know? And then something else about these languages is that they have each specific form of hardware, like a specific CPU, you'll write machine code for that. A specific computer, you'll write machine code for that specific computer. So you tailor make it, you know, like the way we have designer clothes. So that design, or maybe tailor-made clothes, that dress or that outfit is made specifically for you, like your shape. So that's the same thing with machine code and assembly code. The other type of programming language is now the high-level languages. So these high-level languages are languages now that are written in actual English. So you who is writing that code, you understand what you're writing. But now the computer does not understand it. So this is an example of, say, like you say, print hello world. So that is English. And the rest of this, like that is English, you actually understand what you're writing. But now the computer cannot understand it. So it will take time to understand what you're actually telling it to do. So it will be a bit slower than the machine language. And another advantage is that now you can easily, when there's a problem, you can easily know, oh, maybe I wrote a wrong spelling here, or, oh, I missed a comma. So you can easily detect the errors, and that is known as debugging. And you can easily change it, you can easily modify it, you can make it better easily. But you see, if you write 0010, it is so hard. You know, you're even tired of writing it until you don't even want to change it. Like once it works, you just don't want to mess with it. But now with the high-level languages, you can easily change it. So, you know, you're like, okay, fine, you're telling me about these programming languages. And actually, programming languages like have a history. And it's good sometimes to know where all this started from. So in the 1940s, I don't even know, like history, like you read about history in 1940s, that's when people discovered, okay, we have this computer and we can write machine code for it. You remember I mentioned the low-level languages? So in the 1940s, the first generation languages were created in the 1940s, and these were machine code. Machine level. So machine level languages and machine code is basically one and the same thing, which would be 001. So in 1940, people were just there writing 1010001001110, just like trying to make language to make the computer work. They were not writing like the way we can type documents. No, people were using computers like that, and they were really big computers. I'll actually send you guys photos. Like they were big computers, and they used to write machine code like that. So someone came in around 1950s. Someone was like, no, this thing is so hard, so tiresome. So can I make it a bit simpler? So they created the assembly language. And as I mentioned, assembly language has a bit of English. So it kind of made machine language less complicated with some English words. But now these English words had to be translated into a form that the computer can understand. And now they used something known as an assembler. So the assembler translated the assembly language into machine code. So we said the first generation were machine languages, machine level languages. Second generation was the assembly languages. This was around the 1950s. So, okay, so people continued using them until around late 1950s to say like the 70s, 80s, 9, around that time, late 19 to around 70s, 80s, and they came up with now another form of language. Now this is the third generation languages. So this generation of languages is now where people came up with, okay, we are tired of writing zeros and ones. So let's come up with a language that we can understand as humans. And then we use something like, you remember with the assembly code, we used the assemblers. So in this case, they came up with kind of software known as either compilers or an interpreter. So this would now translate what they were writing in English as the code. So the examples of this would be like the languages I mentioned below. So Basic, Pascal, Fortran, those were like the old ones, like the first ones in the like late 1950s, 60s, 70s. Then later on came now languages like C, like COBOL was the first one. COBOL was like the 1950s. And there's actually a lady she's known as Grace Hopper. She came up with assembly language, then came up with COBOL. So you can look into that history. And now came languages like C, C++, then Python, PHP. Python came way later in the 1990s. But C, C++ were in the 70s. PHP and Perl, I think, were in the 80s and 90s. Yeah, I think 80s. So, and these are the third generation languages. So this is now where now English-like languages, like this one here, print, hello world. This is an example of, that is like Python code. So it's not this like English-like words. And so as the years went by, they continued developing these languages and made advancements and stuff like that. So these languages like C, C++, Python, PHP, and Perl, some people call them third generation. Yes, they are actually third generation, but the more they kept developing them, they flowed into the fourth generation languages. So fourth generation languages would be third generation languages that were advanced, that had advancements. They behaved such as like third generation languages because now there's a way these third generation languages had a particular structure. So they behaved that way, but were more advanced and kind of resembled fourth generation languages. So fourth generation languages were languages that had like specific tasks, like say databases or like creating websites. So some of the examples of this are like SQL, Oracle. These are languages that are used to create databases. So a database is like a whole storage where you store data. Like say in school, you know, you have a storage where like all your information is stored, like your name, all your marks, they are stored in a database.
Let's just ask a question.
Okay. Yes.
So like when we were showing the code, like code languages and like here too, I was just wondering why HTML wasn't on there.
Okay.
Okay, so let me answer that. You say you're wondering why HTML is not part of the programming language?
Yeah, I was just
okay. That's a very good question, by the way. Now, HTML was actually invented, I believe, in the late 80s, around 90s, but HTML in itself is not a programming language. HTML is a markup language. So that's what we did.
hypertext markup.
Say again?
No, I said, oh, hypertext markup.
Say one more time, sorry.
I said, oh, hypertext markup.
Yes, hypertext markup language. So HTML stands for hypertext markup language. So we will be able to know why that is not the case, why we're not putting it in the category of a programming language, because it does not have some of the features or characteristics of a typical programming language. Now, let me just give you an overview. A programming language has to have what we call 3 building blocks.
All right.
One of the building blocks, it has to be able to put code in sequence, like one after the other, so that it can be interpreted or translated or compiled. And then another aspect, it has to be able to iterate. Iterate means you can loop, say we enter and then go back and enter again and then enter again. That's what we call iteration or looping. And then a programming language has to be able to make a conditional decision. That means if this, then go to this one. Otherwise, end it. So HTML does not have some of the characteristics of a programming language, but it is a markup language for designing the websites. And we will be able to, next weekend, we'll be able to go through HTML and you'll be able to see, okay? Did that answer your question, Duchess?
Yes, thank you.
Thank you, thank you. That was a good question, very good, okay? Proceed, Esther.
Yeah, so as I mentioned, the 4th generation, like were advancements like this thing, these languages are made better. So as time and even as we continue, all these languages are being made better and better, and more languages are being created. Now would be the 3rd generation languages being updated and some other 4th generation languages coming up. And in today's world, we actually use a lot of these 3rd generation languages and 4th generation languages, but we don't use 5th generation languages as much, because this would be like a language where you just enter what you want and then the language does it for you. Like you as the person, like a programmer, you don't actually like you don't write out everything you want the computer to do. That language, they are called constraints. You give that language the constraints. I want you to do A, B, C. I want you then to do D, E, F. Then the language itself is tailor-made in such a way that it will function that way. So those are the 5th generation languages. So I would like you to pay attention to the 3rd generation and 4th generation languages. And if you find it interesting, look into assembly languages, because some of this, like I mentioned, like the driver software and the firmware are sometimes written in machine code or assembly language, and even some intensive software that might need a lot of CPU power might be written in assembly language, because now it is way faster and it is way closer to the computer. But most of the application software, all like our games, all application software that I mentioned are normally written in the 3rd generation languages. C, C++, Python, like you say, Instagram is written in Python, Facebook is written in PHP, games like World of Warcraft, I think is written in, is it C or C++, Minecraft, I think Java. So different application softwares are written different.
And also some of the language, some of the applications might be written in more than one language. So you find that, for example, Facebook was written using PHP, but you find that in the back of what we don't see, it has to be linked to the database. So you find that PHP is 3rd generation, but it's doing some lifting on the database, and databases fall under 4th generation language. And then you find that Facebook at the front is actually HTML. And HTML alone cannot work, because it works, but it doesn't look good. So we have to dress it up by styling it up so you can make it beautiful. And therefore we put another styling language we call it cascading style sheets. That's very good at chess. That's very good. CSS. So we'll be able to learn this, and then it's like one piece on top of the other. Okay, Instagram, YouTube, those were used, those were designed using Python. And also Python will not work all by itself. Python will be able to work with the databases and also with other, like markup language like HTML. Now we have HTML5. There used to be HTML4. Before that was another HTML. So they also always improve this. And then HTML will not work all by itself. It has to depend on the CSS. And HTML sometimes will also have to depend on the JavaScript. And the JavaScript will probably fall under 3rd generation and transcend, like go into 4th generation, even 5th generation sometimes. So some of the languages, they go beyond certain generations based on what is needed at the time and what improvements are being done to make it work. Say, for example, Swahili or English. When we speak English in the United States of America, our English can be understood by somebody who is also speaking the same English in Europe, let's say in England. And the same person in England will understand, but will not understand some of the dialects, some of the words we speak in the United States, because things have changed. So that's the generational change. And somebody in Kenya who also speaks English might not understand all the English words we speak, as in America. So they'll tell you, oh, your English is more Americanized. You know, so that also basically follow the same trend as the programming languages. So you can develop an application. By the time you're done, you might be able to have used more than 3rd, 4th, and 5th generation languages for it to be what it needs to be. Okay. Go ahead, Esther.
I think I'm done. You can just continue from there because I'm done.
All right, you're done. Okay.
Yep.
So that was a very good session, Esther. Thank you so much. And is there any question before we proceed? Anybody with a question on the languages? Anything you did not understand, you think we may need to put more emphasis on? It's okay. Just raise your hand. Yes, you have a question? I see you smiling. Okay, anybody with any question? Okay, so let me go ahead and give you a summary, okay? We have first, okay, Derek, you have a question. Go ahead, please. Unmute.
I didn't understand in the 3rd generation.
Okay, so you did not understand the 3rd generation language, right?
Yeah.
So, okay, when the computers first came into being, okay, Raphael, let me answer Derek and then I'll answer your question. Okay, when computers first came into being, the computer used to be like very large machines, or even occupying a whole bedroom, or it could be a whole building. We used to call them mainframes. Those mainframes, they did not have any set of instructions. So those people during those days, they used to use what we call like punched cards. So punch cards are just piece of cardboard, paper which is punched in a certain pattern. Those punching on that piece of cardboard was to be in a specific pattern to give the computer certain instruction to work with. That was very difficult. It was time consuming and very slow. So in the 50s, people started thinking differently. Now we can improve on this process. So Derek, what they came up with different languages, and we are talking of the 1950s and 1960s. Some of the languages, one of them was a common business-oriented language. It is still being used until today and mostly in the business and finance. We call it COBOL, okay? COBOL has been in use for a long time and a lot of programming code are still in COBOL. Another language which was also introduced was BASIC. BASIC stands for Beginners All-Purpose, okay, Symbolic Instruction Code. And BASIC, when it came, was basically for educational purposes. It was not for business. COBOL was for business. BASIC was for education, for colleges, for people to learn, okay? And then they also came up with what we call Fortran. Fortran is short for Formula Translation Language. And this was for science and engineering. During those days, it was days when things were changing so fast. You know, we had not even gone to the moon, but the technology was coming in, so they needed some languages to help in that respect. In addition to that, they also came up with another language we call ALGOL. ALGOL is algorithm language. So you see they shortened some of this language. ALGOL is algorithm language. And then those were for like in the 50s and 60s. And most of these languages, which are third generation languages, we call them high level languages because we use English instruction to design the language and give instruction to the computer to follow those languages. The computer don't understand the language. It does not. The computer is not a very smart thing until we give it the right instruction and then we tell it what exactly it needs to do. So these languages come with what we call a translator. And the translator it comes with is what we call either a compiler or an interpreter. Say, for example, Asha speaks Swahili, okay? And then Esther does not understand English. So I understand English. So Asha will tell me in Swahili, and then I translate to Esther in English so that Esther can understand what Asha is talking about. That's translation. So the translation of a computer programming language like BASIC was known as the interpreter. And the same is for Python. We use interpreter. Interpreter means they take one line at a time and read it and then translate it. Read it and then translate it. Normally it's a little slow, but it works. Alternative to that was to bring in the compiler. Compiler will take a whole instruction code and then change it to machine code all at once and then spit it out. So compilers are much more faster than interpreters, so they work faster, okay? Another language which was introduced, but was introduced in 1995 was Java. Java is very popular and is very common, and it's also multi-purpose language. You can use Java in science, we can use it in math, we can use it in business, we can use it in finance. It's general purpose. It can be used for anything you can think of. Java is a compiled language, and Java is very popular, okay? In the late 80s and early 90s, they came up with a programming language known as Python. Python was named after a very popular television series program in Europe at the time, known as Monty Python. But right now, when you look at Python programming language, it's more or less to do with the Python as a snake than Python, the TV series language. So they named Python, and Python is very popular. And the reason why Python is very popular now, even though it's an interpreted language, It's very popular because of the advent of machine learning, data science, and artificial intelligence, and of course the deep learning. So we'll be able to talk about those. We have the data sets, we can process the data and be able to analyze and visualize the data and be able to make decisions. So in data science, it's a combination of what we call statistical mathematics combined with computer science. And then we put decision making it, and then we communicate it back to the community or the public. For example, when you listen to, let's say, the radio or you watch the TV, they give you the weather prediction. They say tomorrow is going to be sunny and a little bit of rainfall in the afternoon. How do they know that? They actually are predicting based on the data which they have from a long time ago, which they can bring in and then use some of the languages like Python to be able to predict, like, let's say tomorrow is going to be Monday. What was the Monday like 10 years ago tomorrow, 20 years ago tomorrow? So they do that, and then they are able to predict the future. They can predict stock market exchange prices. They can predict the sales, like in a business, sales of an item. They can predict how the item is going to sell. So they use artificial intelligence to do that. And in addition to that, of course, I talked about PHP, which is being used very widely in websites, like Facebook is using that. We have C#. C# is also a compiled language. We have Perl. Perl is an interpreted language. So Perl, PHP, and Python, even though they're languages, they are interpreted. Sometimes we call them scripting languages because we can use them for scripting real quick algorithms to be able to give us some kind of models we're looking for. Okay, did that answer your question, Derek?
Yeah, you answered.
All right.
Thank you.
You're welcome. All right, Raphael, you have a question? Go ahead.
Was C++ used to make Unreal Engine?
Okay, say one more time, I'm sorry.
Was C++ used to make Unreal Engine?
What engine again?
Unreal Engine?
Okay, is C++ used to make Unreal Engine?
Yes.
Unreal. Okay, when you say Unreal, what do you mean?
It's a code that you would, I don't really know, but people that create games for
okay. Oh, okay, I see what you mean. So C++ is one of very popular languages, and C++ is derived from C language. C language was invented in the early 60s, okay, by two people, okay? And we will learn about those people briefly, not now though. But when they came up with C, C was very close to assembly language. C is a compiled language. Assembly language is an assembly language uses assembler for it to translate to machine language. C language uses compiler. C is very close to assembler. That means it's very close to the machine at the hardware level. So most of the programming languages we use for programming very fast gaming programs, they use C and they also use C++. Now C++ is just like C, but with a lot of improvement on what we call object-oriented programming. We will learn a lot about objects, like me and you, we are objects. Your computer, your house is an object. So each and every object has a name, Okay, it has some characteristics. Let's say your room or your house it's a building, it's a house, could be a story building, it's on a particular address, the color, how many bedrooms, how many bathrooms. Those are characteristics of a house, as in a house which fits in what we call object-oriented, or we call in objects. So C programming languages is pretty much used to build other programming languages, including PHP, even Perl. They use a lot of C to design these other languages. In fact, C language was used to design Unix operating system, okay? But C++ is an improved C language in itself. So all the game programming engines, most of the very serious game programming engines, they're built using C and C++, because C is very fast and C can address the hardware at very low level. It can manipulate the memory, can manipulate the processor, it can really make it such that it can work very fast. Okay. Did that answer you, Raphael?
Yes.
All right, thank you. Any other question, anybody? Okay. I know you guys, it's a lot to take, but we will go ahead and post the video again. Get time and go through the video. Everything we're covering here is also in your Google Drive. When you get time, just go through your Google Drive. You can go in there through your phone, and then you can also ask questions if you have any question, okay? But these are the basics to help you understand when we get started next week on designing your website, and also later on designing your game, so that you can showcase to your siblings and your friends, so they see what you've been doing. Okay. Okay. Any other question? Anybody? Okay. I know we've gone beyond time. Okay, Godson, go ahead if you have any questions.
I just wanted to make sure real quickly. Wait.
Go ahead.
Can you hear me?
Yeah, I can hear you now.
Okay, so the meeting for today is gonna be in our Google Drive, and the one for yesterday is there too, right?
That's correct. Everything we do, we record it, and then we post it on the Google Drive.
And
The
Classroom.
link, so you click it, you can listen in, and also the notes are on Google Drive, both in the slide and also in your Google documents. So I'll go ahead, before you come back next week, I'll post a quiz. It's gonna be like a 10 questions quiz. It's gonna be very easy with multiple choice. So this will just be able to help you understand what we covered. So everything we do is gonna be available for you out there in your,
okay.
Yes.
Thank you.
You're welcome. Thank you. Any other question?
Is the test gonna be some grade or something like that?
Yeah, it's gonna be graded, but you should not fear. It's gonna be very easy. Once you do it, it automatically grades and then send you an email.
Okay.
It's just to help you understand. Okay, it's not to give you any tricky questions. Very easy to help you understand, to gauge your understanding. Okay.
Okay.
Okay, Godson, you have a question? Go ahead.
We're not allowed to use our notes while we're doing it, right?
Oh, you are allowed to use your notes. Yeah, the test is going to be on Google Drive.
Oh, okay.
Yeah, and then the Google Drive will have the notes for you.
Okay.
Yeah,
Thank
so
you.
everything will be available for you. Just go through it. You can even discuss if you have a friend. I encourage you, if you know each other, you can communicate and then ask questions. This is to help you understand the concept and the material.
Okay. Thank you.
Thank you. Any other question? Anybody else? You guys enjoy the class, huh? I can tell. I'm very happy for this opportunity, and I really appreciate you for coming in. I know you could be doing something much more better and interesting, but you chose to be with us. And that really means a lot to us, okay? So until next week, we are going to go ahead and wish you well. Be nice out there, and be respectful and listen to your parents, okay? We'll see you next week, all right? You have a good time, everyone. Thank you very much.
Bye.
Bye. Cha.
All right, bye.
Cha.
Yes, on.
I have a question.
Okay, go ahead, Derek.
Is tomorrow we have a class?
No.
Class.
We only have classes on Saturday and
Saturday.
Sunday.
Oh,
But the class, the Google Classroom is available. If you want to go in there, you can go in there anytime. And if you have any question, you can put it on Google Classroom. There's a forum, or you can just come and post it on WhatsApp.
yeah. Okay.
And then we'll answer it for you.
Okay.
Don't be
Thank you.
afraid. If you need even to call me, you can call me.
Yeah.
Okay?
Okay.
Yes.
Thank you.
Thank you, Derek. You're doing good, very good. Okay.
Bye.
Bye. Okay, Esther, I'm gonna go ahead and stop, and then let's rejoin in. Okay.
Okay.
Thank you.